The oscilloscope is an instrument which makes visible the values, such as time and amplitude, of rapidly varying electrical signals. The following presentation pertains to oscilloscopes and their operation. It presents basic operating terms and operating instructions. All oscilloscopes can be divided into certain basic sections: the CRT and its controls, the triggering section, the vertical section, and the horizontal sweep section. Let's start our presentation with the CRT and its controls. CRT stands for cathode ray tube. The CRT gives a visual display of an electrical event. On the face of the CRT are lines which form a graph. These lines are called graticules and aid in amplitude and time measurements. The graticule of the CRT has an X and Y axis. The X-axis of the CRT is related to time and frequency measurements. Frequency is the number of periods which occur in a unit of time, units in cycles per seconds or hertz. The Y-axis of the CRT is related to the amplitude. Amplitude is the vertical height of the waveform calculated in volts per division. The CRT controls determine the quality of the display. Included are the on-off illumination control, the beam finder, the intensity control, the focus and astigmatism controls, and the mode buttons. The on-off illumination control turns on the oscilloscope and illuminates the graticule. The beam finder locates the beam or signal. It is useful when the trace can't be located on the display. By pressing this button, the beam will appear either above or below the center graticule. Thus, the location of the trace is known and can be correctly positioned on the display. The intensity control determines the brightness of the trace. Making and leaving a trace too bright can permanently damage the CRT's chemical coating. The focus control adjusts the definition of a trace. The focus control works in conjunction with the astigmatism control, which determines the shape of the CRT beam. Ideally, it should be perfectly round. To adjust the shape and focus of the CRT beam, push the XY button and switch the AC ground DC switches to the ground position. This will provide a non-moving pinpoint trace on the CRT. Adjust the focus and astigmatism controls to form the smallest round dot possible on the CRT. This only needs to be checked and adjusted periodically. The mode switches determine which or how many traces will be displayed on the screen. If channel 1 is selected, only the input signal applied to channel 1 will be displayed on the CRT. If channel 2 is selected, only the input signal applied to channel 2 will be displayed on the CRT. In the dual mode, both channel 1 and channel 2 input signals will be displayed. In the add mode, input signals from channel 1 and channel 2 are algebraically added together and displayed as one waveform. To subtract input signals, use the channel 2 invert button. Then press the Add Mode button. This will algebraically subtract the traces. The quad mode will display 4 input signals. In addition, there are 2 modes of switching the CRT beam between 2 input channels: alternate and chopped. The alternate mode is used for viewing high-frequency or high-speed waveforms of 1 millisecond per division and faster. In the alternate mode, first channel 1 is swept, then channel 2. The chopped mode is used for viewing low-frequency or low-speed waveforms of 1 millisecond per division and slower. The sweep is chopped at approximately 250 kilohertz and switched between channel 1 and 2. The pull chop frequency select control permits better viewing of the signal when it approaches the chop frequency level. The vertical and horizontal position controls are used for locating and positioning the channels on the display. Before using any oscilloscope, check the trace location, DC balance, and calibration. To check trace rotation, select the appropriate mode switch and ground that channel's input. Make certain the trace is straight, horizontally, across the CRT. If the traces are not straight, compensate by utilizing the trace rotation screwdriver adjustment. To adjust the DC balance, place the AC ground DC switch in the ground position. Rotate the channel 1 volt per division control through all positions. The trace on the display should not move vertically. If there is any movement between adjacent attenuator settings, compensate by adjusting the DC balance control. Repeat for additional channels. In addition, check the calibration of the oscilloscope and probes. This is done by placing the AC ground DC switch in the AC position. Set the time per division control for 0.5 milliseconds per division and volts per division for 0.5 volts per division. Attach a probe to the channel 1 input jack. Touch the probe to the Cal 1 volt terminal. Then adjust the probe compensation trimmer on the probe itself. If the oscilloscope and probe are working properly, a square wave will be displayed on the CRT. To calculate the correct amplitude of the square wave, count the number of graticules the square wave covers, and multiply this number by the setting on the volts per division control. Remember to compensate for probe attenuation. In this case, the square wave measures 2 graticules, and the volts per division control is set at 0.5, and the probe attenuation is 1:1. This gives the square wave a measurement of 1 volt peak to peak. This should be done every time the oscilloscope is turned on to determine if the probes and scope are working properly. Now, let's take a look at the triggering section, which supplies a stable, jitter-free, useful CRT trace. The trigger signal starts the horizontal sweep. When the input signal reaches the level that has been set, called the threshold, it begins the horizontal sweep or movement. The proper settings depend upon the type of waveforms being observed and the type of measurements desired. The trigger section has quite a few associated terms and controls. Source switch, coupling switch, slope and level controls, and trigger modes. The source switch determines where the source of the trigger signal will originate, either internally or externally. The internal position seeks an input signal from the vertical input jacks. The external position derives the input signal from an external trigger source. The A source switch selects the signal to be used as the sync trigger for the A sweep. On this oscilloscope, it includes V mode, channel 1, channel 2, 1:1 and 1:10 external channel 3, and the line position. In the V mode, each waveform being observed becomes its own trigger signal and is dependent on the vertical mode selected. For example, when the vertical mode is changed from channel 1 to channel 2, the triggering source is changed from channel 1 to channel 2. In the line position, the trigger signal is derived from the input line voltage, 50 or 60 Hertz. In the 1:1 or 1:10 external channel 3 position, the signal applied to the A external channel 3 jack becomes the trigger source. The trigger coupling control has 5 positions. They include AC, low frequency, high frequency, DC, and video. In the AC position, all DC or direct current in the trigger signal is eliminated. This position is recommended for viewing most waveforms. Selecting the low frequency position eliminates the low frequency components from the signal, reducing low frequency hum and fluctuations. The high frequency position eliminates the high frequency components, for a stable triggering of low-frequency signals. The DC position includes the DC and AC component of a waveform. The video position is for viewing composite video waveforms. The slope control allows a choice of triggering on either the positive or negative slope of the waveform. The level control adjusts the start of the sweep to almost any desired point on the waveform. At the extreme positive or negative position, there will be no sweep. With the pull-fix control, triggering always occurs at the average level of the waveform, eliminating the need to adjust the trigger level. The trigger mode has 3 operating positions: automatic, normal, and single reset. In the automatic position, automatic sweep is selected. In automatic, there will be a trace on the display without an adequate trigger. It is used when initially setting the controls and when viewing DC or very low-level signals. In the normal position, the sweep remains at rest until the selected trigger source crosses the threshold level set by the level control. In the normal position, there will be no trace unless an adequate trigger signal is present. In the single position, a single sweep will occur. This is handy for viewing irregular waveforms or instantaneous waveforms. Select the single mode and press the reset button. The next signal will cause one signal sweep. To observe another single sweep, press the reset button. The hold-off control allows the operator to choose, by altering the dead time between the end of one horizontal sweep and the beginning of the next, which trigger to synchronize in a complex trigger signal. Now let's look at the vertical section, which controls the Y-axis, amplitude, or the up-down axis of the scope. The vertical section includes coupling, position controls, the vertical attenuator, uncalibrated lights vernier controls, and ×5 gain. Coupling pertains to the manner in which the signal is connected to the scope's vertical input. There are 3 coupling positions: AC, ground, and DC. The AC position blocks out the waveform's DC component. This position is useful for measuring AC ripple on the output of a DC power supply. In the DC position, all signal components are passed and directly coupled to the input amplifier. The ground position gives a ground reference for performing DC voltage measurements. The vertical position controls allow the operator to position the signal anywhere on the Y-axis. This makes voltage measurements and signal comparison easier. The vertical attenuator pertains to the voltage per centimeter or vertical division on the CRT graticule. By changing the attenuator position, the voltage values on the CRT display are changed, thereby enlarging or attenuating the signal on the CRT. The vertical attenuator can be used to make voltage measurements. First, count the number of divisions the signal covers from its most positive peak to its most negative peak. Then multiply that number by the vertical attenuator setting and any probe attenuation factor. When the vertical controls are uncalibrated, the measurements are inaccurate and the uncalibrated light glows. The oscilloscope would be in the uncalibrated position for comparing waveforms when voltage settings aren't critical. The vernier controls are calibrated knobs found within other controls, such as volts per division and time per division. These controls should be in the full clockwise position if calibrated voltage measurements are desired. The ×5 gain increases the sensitivity of the oscilloscope. For instance, 5 millivolts per division sensitivity becomes 1 millivolt per division sensitivity. The 20 megahertz bandwidth button reduces the frequency response of the oscilloscope for viewing lower frequency waveforms. Now, let's take a look at the horizontal section. It controls the oscilloscope sweep, or the left to right movement of the CRT beam along the x-axis. The amount of time it takes this beam to transverse the CRT is determined by the time base control. The horizontal section includes the time base control, Z-axis, horizontal position control, magnification button, delayed sweep, and trace separator. The time base control pertains to the time value of each graticule division horizontally. A specific time period can be measured by counting the number of centimeters on the x-axis that the time period covers. Then multiply that by the time base setting. Changing the time base setting changes the number of cycles shown on the CRT. To determine frequency, calculate the period of time it takes to complete one entire cycle and divide the results into 1. The X and Y axes are only 2 of the 3 oscilloscope axes. The third is the Z axis. It pertains to the depth of field and varies the brightness of the trace. At the rear of the scope is the Z-axis input. The horizontal position control moves the trace to the left or right on the X-axis, making time measurements easier. The fine horizontal position control makes fine adjustments of the trace along the X-axis. The 10 times magnification increases the sweep by a factor of 10, stretching out or magnifying a signal for a detailed look at specific waveform characteristics. The delayed sweep operation allows viewing of an entire waveform and a magnified section of that waveform at the same time. To use the delayed sweep operation, press button A on the horizontal display and adjust the scope for a normal waveform display. To view the waveform with an intensified portion, pull the Starts After Delay control and press A intensified by B on the horizontal display. The delayed time multiplier knob shifts the intensified portion of the waveform across the display. To calculate delayed time, multiply the change in the delay time multiplier setting by the A-sweep time per division control. To view only the magnified or intensified portion of the waveform, press the B delayed button. To view the entire waveform and the intensified portion, select the alternate button. The trace separator adjusts the vertical distance between the A sweep and the B sweep traces. In addition, there are 2 other horizontal display modes. In the dual mode, the A and B sweeps operate independently. The A sweep is triggered by the A source, and the B sweep is triggered by the B source. In the XY mode, channel 1 becomes the input signal for the Y-axis, and channel 2 becomes the input signal for the X-axis. In this mode, the X-axis can have characteristics other than time. This is used for viewing semiconductor curve traces, Lissajous waveforms, and for direct comparison of 2 voltages.